On Arctic nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts. On the Sun, a star of average size, among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here, the temperature is over 14 million degrees Celsius, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outwards from the core of the Sun. At the outer layers, the heat moves from the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the Sun. In some places, the magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the Sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel for the gas to stream down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora. If you are traveling north in quest for the auroras, your best option will be to travel to the area around the aurora zone. The aurora zone stretches across the northern part of Scandinavia, Norway, Sweden, and Finland, over Siberia in northern Russia, and then across Alaska and the northernmost parts of Canada, and further across southern Greenland and Iceland. It is in these places that you have the best chances of seeing auroras. And the best time period to go is between mid-September and mid-March. The northern lights have fascinated people throughout history, and a few natural phenomena on Earth are able to inspire a stronger sense of wonder in us than the majestic dance of the aurora. In addition to the geographical locality, the chances of seeing auroras depend largely on the current solar activity and on the weather situation here on Earth. While auroras can be seen to some degree on almost every clear night within the aurora zone, The largest and most spectacular auroras appear only during increased solar activity, even at high latitudes. Most northern cultures have a wide variety of oral legends about the aurora, which have been passed down from generation to generation. During the Viking period, northern lights were described as a reflection of the dead maidens, or as reflections of the shields of the Valkyries, the female warriors who chose which slain warriors should be escorted to the Valhalla, the hall ruled by the god Odin, in which the slain spent their afterlife. Many cultures also believed that the aurora was a place for the dead, in particular for people who had died a violent or too early death, people who had been murdered, who had taken their own lives, who had been killed in war, or who had died in childbirth. Other cultures believed that it was a message from the Creator. An old tale from the Nordic countries said that God is angry when the aurora flames. There are many stories about people claiming that strong auroras often are accompanied by sound. Many people still argue that they can hear some crackling sounds, often synchronized with the movements of the aurora. The aurora occurs at heights above 80 kilometers, where the atmosphere is nearly a vacuum. Since sound waves cannot propagate when air pressure is so low, it should be impossible for sound to travel down to the ground.